Hello everyone! Today we're gonna be talking about the electric generator, which was made by me, Vitor, Ivan, Luca, and Matias. So let's start talking about our learning targets for this lesson. So bear with me because there are a lot of things I want you to learn. So first of all, you need to understand the definition of an electric generator. Then you need to understand the difference between an electric generator and a motor. Then you need to learn the components of an electric generator, the importance of the electric generator for our lives, and some of the basic history about the generator. Okay, so let's get down to the definition. So an electric generator is a device that converts mechanical energy into electric energy. So you might be asking yourself, what is mechanical energy? Mechanical energy involves the movement of an object. So for example, you're moving a lever. In this case, a magnet will be moving something to create electric energy. And electric energy is simply the energy we use to power up everything we use in our lives almost. Since you're probably already tired of seeing me conduct energy through my hands, let's see some animations that shows us the difference between an electric motor and an electric generator. So what you see on the screen right now is an electric motor, which is not what our presentation is about. You can observe that its power source is a Duracell battery, which uses its power to spin the armature. What the electric motor is doing is converting the electric energy into mechanical, which we have learned is the energy produced by the movement of an object. In this case, the object is the armature. Now, let's watch as the animation switches from an electric motor to an electric generator. First, the magnet turns around and makes space for a small windmill or fan. In this case, the mechanical energy source will be this little fan. Now, the battery will be replaced by a small light bulb, which will be our power supply. The mechanical energy from the windmill is going to be converted into electric energy. It's going to turn the light bulb on, as we can see. You might be confused right now, so it's time to revise. Although they look alike, the electric motor and generator are complete opposites. And I just want to highlight this again. So the main focus of this lesson is the electric generator. Going back to the topic, they are complete opposites because the electric motor converts electric energy into mechanical energy, while the generator does the complete opposite. It converts the mechanical energy into electric energy. Now we need to learn the parts of an electric generator. First, let's start with the armature. The armature's definition is the rotating part of an electric machine, which consists essentially of coils of wire around a metal core in which the input current interacts with a magnetic field to produce torque. On an electric generator, there is one magnet. I'm not going to say the definition of a magnet, but what you need to know is that both magnetic poles, north and south, interact with the armature, causing a torque, which is a spin. Now let's talk about the brushes. The definition of brushes is electrical conductors that make sliding contact between stationary and a moving part in an electric generator. Now for the definition of the slip ring. It is a continuous conducting ring from which the brushes can deliver the current in a generator. Last but not least, the definition of galvanometer. It is an instrument for detecting or measuring an electric current by movements of a magnetic needle in a magnetic field. Now let's talk about why the electric generator is so important for our lives. So this question comes up. Why is the electric generator so important? Well, you know the company Copel, right? It provides power for the whole city of Curitiba. The electric generator is important because it is used by power providing companies like Copel to give power to our city. So, without the electric generators, we would never be able to use the refrigerator, watch TV, play video games, and even use the fan. Now let's wrap up this presentation with some basic history about the electric generator. This device was created by a man called Michael Faraday in August 1831. He was the first person to notice that a changing magnetic field is what actually builds a magnetic current. The device he built consisted of a tube of a neutral material wound with a coil wire insulated in cotton and a bar magnet. Faraday connected his apparatus to a galvanometer and discovered that when he passed the magnet back and forth through the coil of wire, which remained stationary, the needle of the galvanometer leapt into action, registering the current flowing. Thank you for watching. I hope you learned something about the electric generator. I hope you learned how important it is. Now I'm going to show you the roles of our project and who did what.
DJ! Nós gosta assim, nós tá suave final de semana. Vai achando que é só playboy que vive Copacabana. Aí, dá uma olhada no cordão, tá tranquilo. Aí, dá uma olhada nas bandidas que tá por nós.